Okay, so worksheet 4 from Unit 12. This is the first period video, so we'll do 147 ... I said this already. The test is all with calculator. So the calculator can do all the integrals, and that means you shouldn't have trouble figuring out who's top and who's bottom or right and left, because you can graph them and figure it out. Number 1, the area of the region enclosed by the graph of y equals x squared and y equals x and y equals x squared minus 3x plus 3 is, I don't know. I know what y equals x looks like, and I know what a parabola looks like, but I don't know what that parabola looks like. So let's go to the calculator. Y equals x squared minus 3x plus 3, y1 and y2. So I'm already thinking ahead, top minus bottom. There's y equals x, but my scale is kind of weird, so that looks funny, and I can't even see most of the parabola. So let's see, I definitely need to see more x's, probably need to see more y's. So I don't know, 5 for the x's. For the y's, maybe we go to 5 or 6. I don't know, let's just see. Alright, there's y equals x. There's my parabola. So clearly I know which one's on top. That would be x minus the parabola. I should have used y1 and y2. So what else do I need now? I got top minus bottom. What else do I need to finish this off? What's that? The limits, or the intersections, or the limits are the intersections. So I need A and B. And, without a calculator, I'd set them equal to each other and hope it factors, and meh. But with a calculator, let's just let the calculator do the work. Hopefully they're integers. Yep, x equals 1 is the first, or the bottom limit. Second limit, or the top limit, or the upper limit is x equals 3. Okay, so from 1 to 3, top minus bottom. And remember, when a and b are weird numbers, we usually store them so that we don't have to type decimals. But when it's 1 and 3, there's no need to store that. Math 9, 1 to 3. I'm going to do y1 minus y2 to save myself the typing. y1 minus y2 dx. Of course, the calculator gives me a decimal, and I've got fractions, but that's a pretty easy one. I know what 1.333 is. So 4/3. Number 4. Let R be the region in the first quadrant bounded by the graphs of y equals x cubed. Okay, I know what that looks like. X equals 2. So 2 cubed is 8, so those would intersect at 8 if that matters. And the x-axis. Okay, so my region we're talking about is that right there. X equals 2, x-axis, y equals x cubed. R is the base of a solid whose cross-sections, okay, so we're going to have shapes coming up out of the page, perpendicular to the x-axis, so that means dx, are equilateral triangles. So coming up out of the page are these equilateral triangles. So we need to add up all of the equilateral triangles. The limits are easy because it's 0 to 2. I don't have to do any intersections or anything crazy there. the area of an equilateral triangle, that's the one I mentioned in passing a moment ago. Root 3 over 4 s squared. And s in this case is top minus bottom. Top is this curve, that's x cubed, and the bottom is 0. Obviously it's multiple choice, so I could go to the calculator right now if I wanted to. But I'm going to clean it up a little bit before I go. So root 3 over 4, 0 to 2, x cubed squared. Again, be careful. That's another one where you can let your calculator do that, or you could just type in x to the 6th. Math 9. Oops, I was going to put the root 3 over 4 out front. And fancy with the fraction bar. The fraction bar helps me make sure that I'm square rooting the right thing, not square rooting the 4. So root 3 over 4, math 9, 0 to 2, x cubed squared. That looks kind of funny, but that's right. If you're not sure about the cube squared thing and you wanted to do the x to the 6th, I don't know that I would be doing this during the test, but maybe if you wanted to go back and check it. Right, those should be the same answer. Uh-oh. What did I do wrong? X cubed squared versus x to the 6th. Maybe. That might be the problem. Because it might be squaring the 3. I bet that's what it did, and so that was probably x to the 9th. Let's see if that gives me a better answer. Yeah, there we go. So that was dangerous. I'm glad I checked it. So make sure you're squaring x cubed, or just do it by hand and get x to the 6th. So my answer is 7.918. That's definitely not including a pi. There is a square root of 3 in my answer, so I bet it's one of these. 32 sevenths times square root of 3. Yeah, there we go. Number 7. The base of a solid. Anytime it starts out like that, you're already thinking we're either building shapes out of that or we're going to rotate it. So let's see. The region in the first quadrant, bounded by the graph of cosine of x from 0 to pi over 2. Okay, cosine starts at a max and does that. Ends at 2 pi, so that's pi. Okay, so where it hits the axis is pi over 2, so that makes sense. I guess if you didn't know that, you'd type it in the calculator and play around until you figured out that it looked like that. Let's see. Cosine x, 0 to pi over 2. For each solid, each cross-section perpendicular to the y-axis, this means we've got to be super careful because this is a dy problem, is a rectangle whose height is 4 times its width. It's like there's its width, and its height is going to be 4 times that. So I'm trying to 3D draw a rectangle coming up out of the plane there. So we're going to add up all the rectangles. So base times height would be 4s squared dy. So limits have to be y limits. So 0 to What's the maximum of cosine? Again, if you got a calculator, so if you need it, you can do it. But man, if you're familiar with stuff you're supposed to be familiar with, then it just makes these things go a lot quicker. So 0 to 1, 4s squared. S is right minus left. So the right-hand side is this, which is cosine of x, but why is that a problem? Or why is that not what I want to use? Yeah, it's an x thing, and I need a y thing. So how do I turn this curve from an x expression to a y expression? Inverse cosine. So that means x equals inverse cosine of y. And then left is 0, so I'm not really worried about that. So 4, 0 to 1, inverse cosine of y squared dy. 4s squared, because s times 4s squared. S is this length, which is the inverse cosine of y. Alright, so now I'm ready for the calculator. I feel like most of you are switching to x's, which is fine. I still like kind of emphasizing that this is a y problem, so I'm going to stick with y. But if you want to go with x's, that's fine. Here's another parentheses issue to make sure we're squaring the inverse cosine, not squaring the y. So make sure that the parentheses is in the right spot. .566, and that is one of my answer choices, so yay for us. Yeah, that was kind of a yucky one, because all the dy ones are kind of yucky, and then the inverse cosine, parentheses could have been an issue. All right, we're at 12 minutes. Technically, we should be at 9 minutes, but I think that the 3 minutes per problem, that's like overall. And for these type problems, I feel like these take more than 3 minutes per problem, because there will be some on there that take less than 3 minutes per problem. So again, that's why I'm not worried about the strict time limit for this one. We'll have all of block day. Number 10. Look at this. This is a fairly recent AP test question, 2022. Question number 2 from the AP exam. Let f and g be defined by f and g. Here they are in the picture. Calculator active, meaning you can look them, you can type them in your own calculator if you want. I'm not going to go there just yet. I know what natural log looks like. I know what a x to the fourth looks like, so I can pick out who's who there when we're thinking top minus bottom. The graphs of f and g are shown in the figure on the right, and they intersect at -2 and at b, where b is greater than 0. Okay, find the area enclosed by the graph of f and g. I don't know, you haven't seen a ton of AP free response questions yet, but most of the ones in this section look like this. You're going to find an area, you're going to find a volume, and then they're going to ask you something weird about it. Okay, so -2 to b of y1 minus y2, or f minus g, either one. Since I labeled them y1 and y2, oops, I can use those. But I need to figure out what b is, so that's a calculator question. Natural log x plus 3 x to the fourth plus 2x cubed. Okay. Oh, and I kind of know my scale already. That's nice. So I'm going to go -3 to 2. I'm going to go a little bit past what I definitely need to see. And then y's, I'll go -2 to 2. should be more than enough. So there's my natural log question. There's my x to the fourth graph. We know this one intersects at -2. We're looking for that other intersection. So b equals 0.7819 ... I'm going to store that as b because obviously I need it here, and my guess is I'm probably going to need it more when I start rotating or whatever else they want me to do here. So I'm going to store that as b. And remember, if you exit to the main screen and hit store, it knows you want that value. Okay, so, and as far as showing work, like this is all the work I need to show because the calculator is going to do all that. I've told the grader what b is equal to. I've identified y1 and y2. So yeah, I'm ready to go to the calculator and get an answer. Math 9, -2 to b of top minus bottom dx. Always 3 decimals. 3.604. Please remember to use the store feature, because if you round it, you might not get exactly the right answer. So let's just say I did 0.78. See how close we get. That was close enough. That would have worked. But you don't want to risk that, because maybe it's close enough, maybe it's not. So use the store feature to make sure you get the most accurate answer possible. Part B. For -2 to b, okay, let h of x, oh, I remember this question. Students came back freaked out about this. And you're like, well, just read the question. The vertical distance between the graphs of f and g. So how would you characterize the vertical distance between f and g? How would you measure that in terms of the variables that we have? Just top minus bottom. So that vertical distance is just f minus g. In fact, so it tells us h is equal to f minus g. Is h increasing or decreasing at -0.5? So like right there, is h increasing or decreasing? I don't know, hard to tell by looking. That's probably why they picked that point. What tells me if something's increasing or decreasing? It's a bit of a vocabulary question here. Increasing or decreasing? What calculus thing tells me if something is increasing or decreasing? Slope. That's right. And what's a more calculus word for slope? Derivative. So I want to find h prime at -0.5. So I want to take the derivative of h, and that's just the derivative of f, minus the derivative of g at 0.5. I could go to the calculator and make y3 equals y1 minus y2. That seems a little overkill. I think I'm just going to go math 8, I think it is. Math 9 is the integral. Math 8 is the derivative. So the derivative of y1 at -0.5, whoops, minus math 8, the derivative of y2 at -0.5. Okay, so your calculator can do all that stuff. The grader knows your calculator can do all that stuff, so you don't have to show any more work than that. You don't have to take the derivative by hand, I guess what I'm trying to say. Like, both of those are pretty straightforward derivatives by hand, but on a calculator test, or in the calculator section, you don't have to worry about that. So negative 0.5999999, negative 0.600. So it probably is negative 3/5. It's probably exactly negative 3/5. Oh wait, I haven't answered the question yet. So h is decreasing. Give a reason, because h prime is negative, or h prime at negative 0.5 is negative. You're going to get a section or a piece of each free response question is going to be like that, where you're like, we've never done one like that before. They're always going to come up with something that you've never seen before, and hopefully you can figure it out. If not, if you get everything that you're supposed to know that you have seen before, you're still going to make a 4 or a 5. So again, when you hit the crazy stuff, hopefully you get it. That's bonus for something you missed earlier, but even if you don't get it, you'll be okay. Part C. The region enclosed by the graphs of f and g is the base of a solid. Cross sections of the solid taken perpendicular to the x-axis, yay, dx, are squares. Even better. That's about as easy a volume question as they can ask. So we got squares coming up out of the page, dx. So again, we'll go negative 2 to b. S is top minus bottom. Kind of already did this. That's y1 minus y2. You know what? I'm going to stop writing because that's enough. You've shown what you need to show. This is what you're going to evaluate, and you've told the grader what S is. You've identified y1 and y2. So you've introduced extra variables here, like S and y1 and y2, but as long as you've explained what everything is, not really even explained, just identified what everything is, then you're good. Math 9, negative 2 to b, parentheses, y1 minus y2 squared, because that's the s squared, dx, 5.340. Whoops, volume equals 5.340. A vertical line in the xy plane travels from left to right. Okay, so the line is up and down, but it's moving from left to right along the base of the solid described in part C. Weird. The vertical line is moving at a constant rate of 7 units per second. Find the rate of change.
For that, you need to sign into a Wi-Fi network first.
Find the rate of change, so that's a derivative. So find the derivative, with respect to time, so d dt, of the area of the cross section above the vertical line when the line is at negative 0.5. So I want the derivative of a with respect to t when x is negative 0.5. Okay, well the area was s squared. That was top minus bottom, y1 minus y2 squared. The derivative with respect to t. Okay. Man, it's been a while since we did this. Do you remember what the derivative with respect to t of, let's say, x squared is? You know what? Let's do an easier one. Let's do the derivative with respect to x of y squared. Because that one, I think that's more familiar to us. So what's the derivative of y squared?
2y.
But with respect to x, I need a dy dx on the end of that. It's a chain rule kind of thing. So d dt of x squared would be 2x, but also dx dt. So the derivative of y1 minus y2 squared, like the calculator can do y1 minus y2, the derivative of that squared, but then we need times dx dt. Dx dt. So that's the change in x with respect to time. Well, it tells me that this vertical line that's moving left to right moves at 7 units per second. So that's my dx dt. This is a problem that not many people would get right. So the derivative of y1 minus y2 squared at negative 0.5 times 7. Okay, so math 8, derivative of y1 minus y2 squared at negative 0.5, but then times 7. Negative 9.272. That's a crazy one. My guess, before you move on, I don't remember what the point distribution was. Does that add up to 9? 1, 2, 3, 2. That doesn't even add up to 9. Trying to avoid putting 3 points on that last problem, but it's a lot of pieces. So the first problem was pretty easy. That might only be 1 point of the 9. Second part wasn't too bad. That's worth 2 points. Third part was easy. Maybe that's worth 3 points. The last one was crazy. So, whatever. So if you got the ones you should have got, A and C were pretty straightforward. Even if that's all you got, that'd be 4 out of 9. And 4 out of 9 is on pace for a 3. And then hopefully maybe you got some of part B. Part D was kind of a weird one. But again, even if you got just the basic parts of it, you'd make a 3. Or you're on pace for a 3 anyway. 10, 13. I hope the other classes watch 13 because, I'll say it in a minute. The inside of a funnel of height 10 inches has a circular cross-section that's shown in the figure on the right. By the way, this is another old AP test question, so we're not making stuff up here. These are good ones. At height h, the radius of the funnel is given by that expression. Oh, this is no calculator. H goes from 0 to 10. R and H are in inches. Find the average value of the radius. This was the bonus on the last test, I think. And not very many people got it. Average value of a function is 1 over the width times the integral of the function across the width. So the average value of the radius would be the integral of the radius. Radius is changing with h. H is going from 0 to 10. So there's my expression for the average value. And without a calculator, I got to do this by hand. Oh, but that's not too bad. The integral of 3 plus h squared. I'm going to pull the 1/20th out front. So that's 1 over 200. Antiderivative of 3 would be 3h. Antiderivative of h squared would be h cubed over 3. From 0 to 10. That is not calculator ready yet. Right? I mean, it sort of is. It's like graphing calculator ready, but it has to be like scientific calculator ready. And it can't have any calculus left in it to leave it. So no, I can't leave it like that. I can't leave it like this either. I need to plug in the 10 and the 0. But I'm close. I'm close to calculator ready. 3 times 10 plus 10 cubed over 3. If I plug in 0, I get 0, so I'm not even going to worry about it. So there's my answer. And I guess in some sense that's not a very helpful answer because I don't know what that is, but it's safe stop. But the big thing with that one was average value versus average rate of change. A bunch of you tried to do average rate of change when I asked for average value. Average rate of change, that's just Algebra 1 slope. Average value, that's a more complicated calculus thing. Even teachers get that mixed up on my favorite Facebook group. A teacher commented, "I'm having trouble with average value versus average rate of change. Is there really any difference in those?" And like all the calculus teachers are like, wait, of course there is. These are the two things and all these. So even the teachers occasionally get things confused. All right, the volume of the funnel. The volume of the funnel. Let's see. So like this looks like cross sections are circles. So I'm going to add up the circles. So I'm going to add up the disks from 0 to 10 as my h is changing. I'm going to add up the disk from 0 to 10 as h is changing. The disk area is pi r squared. There's pi r squared from 0 to 10. So this was a volume that was, you could think of it as being made by revolution, but it didn't walk you through that. You had to recognize that this is a solid of revolution. So we can do dh slices and add up the pi r squareds. By hand. All right, if I square 1/20th, I get 400. So pi over 400, 0 to 10. Square the inside, that's 9 plus 6h squared plus h to the 4th. Again, you're taking an AP calculus test. We don't have time to mess around with foiling things and showing your algebra. Like you got to be able to do this stuff. So that's, if I square 3 plus h squared, this is what I get. Now that integral is pretty easy. 9h plus 6h cubed over 3 plus h to the 5th over 5 from 0 to 10. I sense a safe stop in our near future, but we're not there yet. So pi over 400. Plug in 10, that's 90 plus 6 times 10 cubed over 3. Again, there's lots of reducing that could be done here, but why bother? 6 over 3, that's 2. 10 cubes is 1,000. Who cares? 10 to the 5th over 5. I plug in 0, I get all the zeros, so there's my volume. Ugly as it is, that's my volume. Part C. The funnel contains liquid that is draining from the bottom. At the instance when the height of the liquid is 3, and h equals 3, the radius of the surface of the liquid is decreasing at a rate, so dr dt is negative because decreasing, 1/5 inches per second. At this instant, what is the rate of change of the height of the liquid with respect to time? So find dh dt. R is equal to 1/20th 3 plus h squared. I'm going to go ahead and distribute the 1/20th. It's a hard one. I want dr dt to show up, and I want dh dt to show up. So let's take a derivative of t, or derivative with respect to t of both sides. So that means dr dt is equal to, what's the derivative of 3/20ths? 0. Put the 1/20th out front for h squared. What's the derivative of h squared? Sort of. dh dt, because I'm doing it with respect to t. So 2h dh dt. Okay, do I have all these pieces? dr dt they gave me, h they gave me, and I'm trying to find dh dt. So dr dt is negative 1/5, 1/20th, 2 times 3 dh dt. Alright, now how do I want to not mess up the algebra on this? I'm tempted to multiply by 20 and divide by 6 and not reduce anything. Right? Like it's an option. So negative 1/5 times 20 will fix that. Divided by 6 will fix that. There's dh dt. Sure, it reduces, but that's your problem, Mr. Grader. If you want to know that any further, knock yourself out. 4/6 would be 2/3, so negative 2/3 is the best answer. Well, maybe not even the best answer. It's the most simplified answer. The best answer is the answer that doesn't have any mistakes in it. Those seem to be about all equally difficult to me, so I would say the point distribution is probably 3, 3, and 3. Hopefully, after recapping what average value is, hopefully you get those three. Volume, I mean, if you remember it, maybe. Related rates, maybe. It's been a while since we've seen that. So hopefully after review, you'd be better set to do that kind of problem. All right, well, that ends the third that we wanted to work on in first period.